In this video, I'm just going to extend a previous video about how to work with quadratics that have a lead coefficient that aren't 1, and you want to factor them. All right, so I said in general, hey, that looks like this, and if it looks like that, then the left side can be the right side, and the right side can be the left side, and life is good. So we're going to try a different one here. So let's go ahead and start on this one. Now I said you could probably just start by factoring out the front and the back, and yeah. However, there's a little trick here, and it's not really a trick, but some people think it is. If I have something in the neighborhood of ax plus b, and I want to square that, then to square that, I square the first, which is a squared x squared. I square the last, which is positive, so that would be b squared. Then I multiply the two things inside and double it and keep the sign in the middle. Okay, so now this is known as a perfect square trinomial, or some books refer to it as the square of a binomial. Either way, it gets the job done. But what you can look at is you can look at the numbers out in front and notice that they are in fact perfect squares. Well, man, if they were perfect squares, we could just go ahead and reduce it down to this and life would be good. The only one catch. Here's our check. First of all, we have to make sure that the back is positive, and we have to make sure that the front and back are perfect squares. And so we take a look at it and say 4, yes, 4 is 2 squared, 25 is 5 squared. The 25 is positive as well as the 4. Life is good, so we move on. Now, it's just quicker, trust me, it's just quicker. Assume that it just goes ahead and factors as a perfect square. We're just going to do that and check it to see. And so what we do is we take the root of the first, you notice the a squared, kind of going backwards. So what did you square to get 4? You squared 2. And you squared x to get x squared. And you squared 5 to get the 25. And then you bring down the middle sign. So we think it's going to be this. Well, how do we check? Well, we multiply the first and last numbers. And so we get 5 times 2 is 10. And then according to this, we double it and we should get our middle term. And when we double 10, we get 20, which is not the middle term. Well, it was a good try. Now, ask yourself, how long did that really take? 10 seconds? I mean, it's so easy. Just go ahead and check. What's the worst that could possibly happen? It doesn't work. There's 10 seconds gone. If it worked, you just saved yourselves 3 minutes. All right, it didn't work, so now we have to go to our backup, and that is to find the two magic numbers in the front and the back that when you rearrange them will combine to give you that middle term. To do that, we know that the front and back have to have factors. Well, it's either 1 or 4 or 2 and 2, and on the back side it's either 1 and 25 or 5 and 5. So what we have to do now is we have to work with these numbers, multiplying them in different ways and then combining them to see if we get that center term of 40. Here we're going to use our signs to help guide us. This says that the signs of our factors are the same, and it tells us that we have to add to the middle. Meaning that when we combine for instance, when we say 1 times 1 is 1, 4 times 25 is 100, 100 plus 1 is 101, and that's not 40, so that doesn't work. So we try different things. All right, so if you're really good, by the way, I use my fingers when I do this. You can't see it, but I'm actually like pointing at the screen and saying, hey, I'm putting these two together. That just helps me out. I mean, I'm kind of slow when it comes to that. So anyway, this center sign here, let's go back here and just kind of review this. The center sign tells us the sign of our larger pair. Sign of larger pair. And this is the absolute value of that pair, by the way. So if this were a negative sign and we found out that 1 and 5 and 4 and 5 worked, and then 4 and 5 is 20, 1 and 5 is 5. The 20 would dominate. And so if this were a negative, the 20 would get the negative. More into that later. Okay, so now the important thing here is we need to start multiplying these pairs together, front and back, and then adding those products to see if we can come up with 40. Let's try it. We already tried 1 and 1, and so we'll try 1 and 25, and we'll try 4 and 1. And when we do that, we find out that it's 25 plus 4 is 29. That is not 20. Okay, that didn't work. So now 1 and 4 did not work with 1 and 25, so let's go back to the other way. Now you notice we have two 5s. If we just check one way, it's going to be the same the other way. So 1 and 5 is 5, 4 and 5 is 20, 20 plus 5 is 25, that is not 40. So 1 and 4 do not work with either of these. And so I'm going to cross off 1 and 4. It doesn't work with either of those pairs. Now I go to 2 and 2. Well, I know right away that 2 and 2 and 5 and 5 don't work because then it would have been a perfect square trinomial. Already tried that. Don't have to check it again. So the only thing I got to do is try 2 and 1, it's just 2. 2 and 25, which is 50. 50 plus 2 is 52, which is not 40. Those didn't work. And so, because I could not find any remixing of the factors of the front and the back to recombine into the middle, this is not factorable. In integers. That's not to say that it's not factorable. If you haven't come across quadratic equation yet, or quadratic function, I should say, then you probably don't know what I'm talking about. However, if you have come across a quadratic formula, you know that you can still factor this. It's just not going to be pretty. And this one, in particular, involves imaginary numbers. We're not going to go there. So, because we could not find any pair that would recombine in any way to come up with our center number, yeah, it's not factorable. But the idea is the same. Let's go ahead and give it a try.